Hey guys, welcome back to our Suguru Solver in Python series. Today we're actually going to be writing the code for the solver, so without further ado, let's just jump right into it. So I'm just in here in my terminal right now, and I guess I can probably just make a file for this. So Suguru Solver, cd into there, and then I'm going to open Visual Studio Code to actually write the Python. Alright, so we're going to need two files here. We're going to use one just called suguru.py, and that's where we'll actually implement kind of the functions, and then we'll just have a main.py. Okay, so inside of the Suguru py file, we're going to define a few things. The first thing you want to do is you want to have a class for the tile. So if you think about the board, it's made up of, you have a board maybe 3x3, and it's made up of all individual tiles. So there'd be 9 tiles. So we can just do class tile, define init. This will be like our constructor. We'll take in color, number, and group. So this would be, the number would be, if we're given maybe a 3x3 grid, and there's certain tiles that are initialized with numbers, this would be one of them. And then also remember that each tile belongs to a specific subgroup within the problem. So let's just add these. Self.number, self.group equals group, and then self.color equals color. We're going to also define has number. Just going to return if there is a number set for this specific tile, because remember there could be a tile which doesn't have a number yet. And then in a group, we'll just return self.group does not equal none. Okay, cool. So we have a basic kind of tile. I forgot to do two things actually at the top. We want to import a random and also import Pygame. And if you don't have Pygame installed, you can actually just open up the terminal, do a quick pip install Pygame, and that should only take a few seconds. It's not too big of a package. So I'll let this load out, and then I'll be right back. Alright, so I finished installing Pygame. Now we can actually continue on. So I'm just going to make a class, and we're just going to name this Suguru, and this is going to kind of implement our basic logic. So we'll add our constructor. We're going to take in an X, a Y value. These correspond to the rows and columns of our board. We're going to take in block size. We'll set that as default to 50. And the background color, we'll set that as default to, it should be white. Okay, now we're going to initialize these. I'm using the underscore syntax because, or I guess this is just more of a stylistic thing. But in Python, there are no private class members, so this kind of indicates that we shouldn't be messing with these from the outside. Okay. Block size, just initialize that to block size. The width, take that. Block size times X. So this will be the width of the board, and we'll use this when we're kind of setting up our Pygame. And then we'll just do block size times Y. And then the background color, and obviously set that equal to background color. Okay, now so the self.color and also self.key. So everything here is pretty self-explanatory, right? X will be the number of columns, Y will be the number of rows, block size, width, height, those make sense. The key and the color, these two are going to be kind of the defaults, when we start actually placing the blocks, each block has a key specified with it, right? And that kind of designates the group. So when we are selecting blocks that are in a certain group, they'll all be given the first key. And then when we want a new group, we'll increment that key to say 2. And then we'll set all the group, or all the blocks which we want in the second group, will have that key. And then also the color, that's like the same kind of concept as the key. We will give this color to all the blocks that we select in our first group. Okay, and we can just do get random color, and we'll implement that later down the line. And then board, we are going to have an array of tiles, give it the background color for I in range X, for J in range Y. Okay. For I in, there you go. So basically what we're doing here, right? X would be our columns. So we're going to iterate from 0 to the number of columns, and we're going to create a tile for each one. And then we're going to iterate for the number of rows, and we're going to create this whole thing for the number of rows we have. So this will be like a 2x2, or sorry, not a 2x2, but a 2D array. In Python, we call those lists, but this will be basically a 2D array in which we have each tile object. Okay. And then we want to store the group somewhere, so we're going to be grouping the tiles, and we can just set that like so. Okay. Now we're going to get into the actual fun part of the algorithm. So this is the recursive backtracking part. Okay, so this will be the solve method to our Suguru class. Just taking self. Okay. So the first thing we want to do is we want to make a copy of the board. Okay, and we'll just name that BO. So when we don't want to be using the actual board, because when we use this function recursively, which we're going to do, and we want a separate copy within each recursive call, or else it might interfere with calls like up the call stack. Okay, first things, we'll do this. We'll say if self.solve, okay, of the board, and self.groups. We're just going to print success. So this will actually be our solve method right here. This is a private one. This is kind of a wrapper method almost. And then else we can just print invalid board. So if we can't solve it, that means the board's unsolvable. There's probably a chance that we entered in the board wrong. And then we're just going to reassign self.board to BO. And I should also say that when we pass in BO to self.solve, it's gonna edit it for us, so we can just reassign at the very end, like so. Okay, so the next thing we do, we'll implement this actual solve method in a few minutes, but the first thing we need to do is we need to actually read in our board, because this is how we're going to have all the information pertaining to our board. So we'll just say for I in range length of self underscore board, for J in the range length of self underscore board of I. So we're just iterating through our two-dimensional array. Tile equals self underscore board of I and J. So this doesn't really matter which order we do it in. We just want to read in each tile in our board. And if the tile dot group is not in self underscore groups. So when we fill out our board, we're actually going to associate each group with a certain color and a certain, like a key. You can see that up here. Yeah, group. So this is going to be like a key value that, you know, designates which group it's inside of. So if the tiles group, so let's say this tile is given a group of 3, but it's not in self.groups, which will be our dictionary holding all the keys and all the numbers that are stored inside of the certain group. So if it's not in self.groups, we need to add a new key in there. So we can do that by saying self._groups of tile.group equals right. So this number on the right is designating how many tiles are within this group, and this number, or this array on the left, is actually going to hold the numbers that we know are in the group. So for example, let's say we have a group of, it's like this, like 1, 2, 3, 4. So it's kind of like an L in Tetris. But let's say only this block, only the top block has a number designated with it. We still need to know that there are how many blocks there are in that group, but we cannot really tell the numbers because 3 of the blocks don't have numbers associated with them. So this value on the right is going to tell us that there's 4 blocks within the group, and the array on the left is going to tell us which numbers are already in the group. So for example, the top one was number 1, then we know that 1 is in the group already. And that's going to come in handy when we're actually checking which numbers will work for a certain group. Okay, so now we're going to actually check if this tile has a number. So if tile has a number, we're going to say self._groups of tile.group of 0.append tile.number. So we would append that number inside of here. I hope that makes sense. I think it should make some. Okay, next part. So if the tile group is already in self.groups of tile group plus equals 1. So we would add, here. Yeah, so we would add 1 to the count of tiles within this group. Okay, and if the tile has a number, we need to insert that number into this array. Hopefully that makes some sense. So let's say, let me pull up a quick Suguru board. So let's say this is our Suguru puzzle. So after we read in the board, we'll have knowledge. Each of these groups will be given a key. So let's say this group is key 1, this group is key 2, this group is key 3. Right? We'll know how many tiles are within this group. So we'll know there's 4 tiles in here. We'll know there's 5 tiles in here, and also 5 tiles in here. And then we'll also know the numbers that are already present. So we know that in key 1 or group 1, we have the number 1 present, and we have 4 tiles. Okay, so that should be good. And that's all within our read and board method. Okay, now we're going to add, this is going to be another kind of method that will run from within our actual game loop. So this just increments the key that we're currently on. It's pretty straightforward. And then we also want to generate a new color. Just say self get random color. Okay, so like, let's say basically what we're gonna do within our game is we're gonna use 3 keys. We're gonna use like a Q or like a click or something, and when we press Q, it's going to actually increment the key, and that's gonna designate that we're punching in a new group. Okay, and then we'll define actually get random color. It's finally time. Okay, obviously need to pass in self. And we can seed this with our key actually. I think that works. And then we're gonna return a tuple of random dot randint between 0 and 225 for in range 3. So it's just gonna give us it's gonna first make an array of 3 random integers between 0 and 225, and then we're just going to turn that array into a tuple. Okay. So now would it be a good time to, yeah, I think now would be a good time to write the actual solving algorithm and the validation algorithms. So this is kind of the pinnacle of what we're going to be doing. So we'll have this method called solve. Inside of it, we will take in a board. And okay, so first things first, we're going to do self.find empty. So this is going to find an empty position on our board. And for consistency, let's just find this find empty method right here. Okay, so basically, let me pull up the board again. So this find empty method is going to find the next empty space within our puzzle. So if we were given this basic puzzle right here, the first empty block it would give us would be this one right next to 1. And let's say we fill in a number for that one, then it would find this next one right here. So it's kind of going through that process of finding the next empty block. Pretty self-explanatory. So we'll do for I in range, the length of, okay, we need to pass in our board, and then for j in range, length board of I. So we're just going to be traversing this 2D array, and if not board of I of j has number, then we can return board of I of j dot group. So we'll return the group it's in, we'll return the I and the j values. And otherwise, if we go through the whole board and not find one piece, then we'll just return nothing. Okay, so basically what's going to be happening is we'll be iterating like this, like so, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then once we run into a tile which doesn't have a number, which would be this tile right here, we're going to actually return that tile as group. So from our previous example, this would be a group 1 or key 1, and we're going to return the row in the column. So this is in column 2, row 1. Okay. So first, after we find the piece, we're going to now check. So if not find, then we're going to return true. And else, we're going to extract that information, tag row call equals find. Okay. So if we did not find anything, if not none, so if true, we're going to return true. So this is the instance where we have a number for each tile within our board. And if we have a number for each tile within our board, that means our board is solved. So in that case, we can return up the call stack and return true. And then eventually that true value will be extracted at self.solve, and we'll just print success. And if, let's say, we cannot, or we'll get into that later. Yeah, so if not, none. If true, that basically means if true, we're gonna return true. Otherwise, we've found a empty tile and we're gonna actually extract that. We're gonna say the tag, which would be its key, and we're gonna have the row, which would be the row, obviously, and then the column, which would be the column, obviously. Okay, so now we will iterate from 1 to keys of tag 1 plus 1. Okay. Forgot to take in the keys right here, but that should be good. So this is going to iterate from 1 to, or I mean, let's go back to our groups, right? So we're actually, this keys value, you can see here, corresponds to self.groups. So when we're indexing the tag, it's saying, all right, give me, let's say our tag is 1, so let's say we're in this group. It's gonna give me that array with the array inside of it, and also the number of how many tiles are within the group. And we're gonna actually be focusing on the number of tiles. So in this case, when we return this tile right here, keys of 1, the key is 1, right, for this group, of 1, so it's gonna give me the amount of tiles in group 1, which is 4, and it's gonna add 1 to it. So we're gonna be iterating from 1 to 5, but 5 is not inclusive. It's 1 inclusive to 5 not inclusive. So it'll be really 1, 2, 3, or 4 are our options that we can try and place inside of this tile right here. So if self valid board I row call keys, we'll define this valid method in a second. Self.board row call number equals I. I'm going to copy our keys of tag of 0, copy keys of tag Okay, so I just wrote in a few lines of code right there, and let's actually dissect what's happening. So we're gonna try and validate what this position is. So don't worry about this now. We'll get into that. But if it's valid, if the number that we're inserting into this tile right here, if it works, so if it's not touching the same number horizontally or vertically by one tile. So let's say our number is 2. There couldn't be a 2 here, here, or here. So if that works, and if there is no 2 in the group, then our position is considered valid. And in that case, we can actually set that tile's number to the number we selected from this for loop. Okay, so we would set it to 2. Now the next thing we want to do is we want to copy the keys. Keys of tag of 0 dot copy, right? And then we want to append that number into there. So this is basically just so that we do not overwrite it within future recursive calls. So we're actually going to make a copy. It's kind of similar to the concept we did up here when we copied the board. We don't want our other recursive calls to interfere with it. It's just a little bit of a quirk about Python and how they do memory references and stuff like that. So we copy this this array, which is holding the numbers within this group. So if we copied, when we make a copy of this, it would just be an array with the number 1 inside of it. Okay, and then we would append in the number that was valid for this next tile. So 2 was valid, so we would append in there 2. So now our array is 1 and 2, and now we're going to call solve again. So we're going to recursively call solve. We're going to pass in the board and also our keys, which we just updated by appending in that number. Okay, so if it's true, so if we get to a base case, right, the only way this solve returns true is if we return true from here, right? Because at the end we're actually going to add return false. Okay, so the only way this returns true is if find empty returns none. So if we fill out a number for each tile, then this returns true, and it recursively calls true until we get to the top of the call stack. Now if this doesn't return true but instead returns false, then we're actually going to set that tile that we just had, so this tile right here, we're going to set its number to none, and we're going to restore our keys to what they were previously. Okay, so I hope that makes some sense. Let's define, next we're going to define the validation method. So this method right here, checking if our position is valid. So let's do that. Define valid, self board number, column keys. Okay, so if num, then keys. So this is the first check. So if the number that we've selected from this for loop is already in the keys of board row, so if it's in this group, which is 1, if it's in the keys already, so let's say right now for group 1, we know that there's a number 1 already present, and let's say we select 1 from this for loop, then obviously we return false because we cannot have duplicate numbers within the same group. Okay, so that's the first check. Okay, so we're going to be checking, now we're going to be checking if there is a number touching horizontally or vertically, right? So if we have a 2 here, and there's a 2 also right here, or a 2 here, that would not work. So let's first we need to really take into account our bounds checking, right? We don't want to index something that's out of range, right? So we'll say if board of row, first we're going to check this this tile up here. So board of row -1 of column equals number. Okay, but if, let's say for instance, this is out of range, which it is in our case, let's add one more check. So if row -1 is greater than 0 and okay, So this should prevent us from falsely indexing out of range. Okay. Return false. So if this number, or if this tile's right here, if its number equals the number we're testing, then we cannot put the number there. Next, we'll check this tile down here. So if row plus 1 is less than self.y minus 1, and board of row plus 1 of call plus 1, and that number equals none. And then we can return false. So let's say we're on row 0, 1, 2, 3, 4. Okay, so this one should be if row plus 1 is less than self.y. So let's say, for instance, we have a block right here, and we're checking beneath, right? This block would be in row 0, 1, 2, 3, 4. Okay, so we'll add 1 to that, which would make it 5, and self.y is 5. So in that case, this would fail, and we would short circuit our evaluation. Okay, next we want to check the left and the right. So we'll say if column minus 1 is greater than 0, and board of row of column minus 1 dot number equals none, return false. So if we have something that's in this column right here, if it's in column 0, we would subtract 1 from that. Negative 1 is not greater than 0, so we would fail that. Yeah, so sorry, it should just be greater than 0, because if we were in row 0, we shouldn't be able to move up 1 row, right? So we're in row 0, 0 is not greater than 0, so this would fail. Okay, and then the last one, I'm guessing we can just do call plus 1 is less than self.x, and board of call dot number equals none. Not right, call plus 1. Okay, that should be all we really need. And then if we pass all these, we can just return true. The algorithm is perfectly in place now, but we want to actually add a GUI so that we can use this application. So let's get into that. Let's do our render method, and then let's go into the main. And we're actually going to define kind of our game loop and how it'll work so that we can get some meaning from these algorithms. From Suguru, import Suguru. Okay, so we're importing our Suguru board. Import Pygame. Okay, and then if name equals main, we're going to take in our amount of columns. We're going to take in our amount of rows. Oops. Missed the parenthesis. And then we're going to initialize our Suguru board. And then we will do our screen size. So this is get dimensions method, something we're gonna have to implement. We're using this so that we can initialize our Pygame window, which we will do right here, pygame.init. pygame.display. We'll set the display caption to Suguru Solver. We'll set the screen display set mode. Size of 0, so this will be our screen width and screen size of 1. Right. Okay, this takes a tuple. And then we actually have our game loop. So we'll just set running equal to true. It'll always be running while it is running. We'll add a render method, which we will implement in a second. And then we're going to read in some sort of event, keyboard event, and type equals pygame.keydown. So if the key is a digit key, then we know that we're going to be inserting a number. And we're going to get our mouse position. And then we're going to insert number. We're going to get the actual number we want to insert, and then we're going to insert it into that position. So basically, how our game works is we will hover over a tile like this, and Pygame's going to read our mouse position, and when we press a number key such as 2, it'll insert 2 into that tile. Okay, so now we have a few other keys we're going to be working with. If event key equals pygame.keyS, we're going to Suguru read and board, Suguru.solve. So S would be like our solve key. Key equals pygame.kq. So this Q button is going to highlight a tile as a certain group. So let's say we hover over this tile and press Q, it would give it group 1. If we hover over this tile, it would give it group 1, 2. And we keep on pressing Q, and that's how we create our groups. And then the last thing is event key equals pygame.key. We're going to increment our key. So this is when we want to have a new group. We'll press A, and then we can create a new group, like make a group for this, and then we press A, and then we can make a group for this by pressing Q. Fix this. Okay, and then last but not least, the event type equals pygame.quit. So this means we're going to quit. We'll just set running to false. That'll exit it for us. And let's fix this typo. Okay, so that should be it for our game loop. It's pretty straightforward. But you can kind of see the methods that we need to implement now, right? We need to implement, we've already implemented read in board, but let's see, like render would be a perfect example, highlight board. We need to actually go in and implement these methods. Okay, so we'll start off with the easiest. We'll just do define get dimensions, and we'll just return a tuple self.width and self._height. So this will be the width and height of our board. Okay, we'll do define insert number in the X and the Y positions. So here, we read in the mouse for insert number. We're reading in the mouse X and Y positions, and then we're gonna take those as input. given those x and y's, we're actually going to calculate which row and column it's in. So if we were hovering here, this would be, row 0, column 0. And then we're going to set that tile that is there. We're going to set its number to our given number if the number is not equal to 0. If the number is equal to 0, we're actually going to set that to none. So that would be effectively clearing the number that is in that block. Okay. Read and board is good. Highlight board. So this is where we are assigning groups to our board. So let's define that. Similar to the other insert number, we're going to calculate the row and the column. We'll actually just copy this logic from up here. Right, we're going to get the row and the column, and then we're going to set the tile. So we're going to grab this tile. It's going to be the board, row of call, and then we're going to set the tile group to our current key, and we're going to set the tile color to our current color. Okay. And then we only have one more method, last but not least, obviously, the render method. So let's define that. We're going to take in the screen. I don't know if we passed that in, did we? Yeah, I don't think we did. We have to pass that in here, screen. Okay. So we're going to do screen.fill with the background color. Set our font to Pygame font free sans bold dot true text font. So we'll just set that font, and then we want to iterate another double nested for loop. So we're going to get that tile's color, and then we'll see if it is in a group, and if it is, this is just the dimensions of the block. So it's an X, this would be an X, a Y, and then a width and a height. So we're going to specify the X coordinate, the Y coordinate. You can check out the Pygame documentation for this, and then just the width and the height for this rectangle. So we only draw in color if it's in a group, and therefore by definition it has a color. And if it has a number, then we need to actually write that number inside. So we'll first get that number. Once again, this is pretty much just cookie cutter stuff from the Pygame documentation. So this is rendering a text element. Our text will be corresponding to the number. So this code right here is pretty much just drawing a number into the rectangle. or into the tile. If you want to get a kind of deeper analysis of what this code actually does, you can look at the Pygame documentation, but I'm fine telling you guys what it does. It's nothing you should memorize at all. So then the final thing we're gonna do is draw lines so that we actually have a grid, right? Okay. Draw line. Draw it to the screen. We'll give it a color of 125, 125, 125. So this one is drawing the vertical lines, right? And then we just want to change these dimensions a little bit, right? 0. Okay. And then the last thing we have to do is, okay, we need to fix this level of indentation actually. Okay, last thing we want to do is update the display with just a pygame.display.update. So let's see if this works. This should be good. I think we might be finished. Let's give it a whirl. So enter the number of columns. Let's just exit it out of it. But let's pull out that Suguru puzzle again. So we'll imitate this one. So this one has, looks like a 5 by 5, right? Yep, 5 columns, 5 rows. Ah, I see. Okay, so it should have opened for you guys if you're using this right, but I'm actually using YSL, which is Windows Subsystem for Linux. So they normally do not allow programs, graphical user interface programs to be run within YSL. So you have to use a server like Xserver. So let's give it another try. Hopefully this works. If not, okay, cool. So it worked. Okay, now let's copy in this board. So remember, we put Q for designating groups. So if we hover over tile and press Q, it should assign it a color. And let's do that. Okay, and now we press A, and that's going to change our key and also our group. So we assign like this, and then we can do this one right here too. Individual group right there. Got this big group right here, and this one right here. So you can see that this is how we're identifying our groups. And then we're gonna hover and insert some numbers. So we can just hover over tile and press a number. You notice if we press 0, it clears out the number. Okay, just keying in these numbers. 5. Okay, now the moment of truth. When we press S, it should fill out the board for us. Perfect. All right, we did it. So if you look at this board, you can see it's got the correct solution for us, right? 2 is not touching. You have 1, 2, 3, 4, right? 1, 2, 3, 4, 5, right? By all looks, this is a valid board, so our goal is done. Alrighty. Now you can obviously enter more difficult puzzles. In fact, let's do this one. This one looks just for fun. For fun, let's try and do this one because I don't think I've really tackled a board like this before. So let's try it. Okay, let's make sure I know to count. Right, there's 9 columns, and how many rows are there? There is 7 rows. Oops. Okay, so this is going to be a fun challenge. Let's see if our algorithm is good. Okay, so we'll start filling it out. filling out these groups. I'll probably fast forward this just so you don't have to sit and watch me fill this out. Okay, so by all looks of this board should be right. Hopefully didn't mess anything up, or else that would be awkward. It looks good. Also, I'll just demonstrate this now, but let's say you were to mess up a group. Let's say you accidentally added this one right here, right? So you can't really go back, but you can just refill it out like that. So, okay, the moment of truth. 3, 2, 1, S. Perfect. Matter of seconds, it fills it out for us. So never again will you have to waste time doing a puzzle like this. But more importantly, we kind of saw like how to solve a problem using recursive backtracking, right? Seemingly very complex, like you wouldn't want to try all the possible combinations, but by using recursive backtracking, we can actually build up a solution by testing different combinations. So I hope you guys enjoyed the video. Like, comment, subscribe if you enjoyed. I'd really appreciate it. But stay tuned. I'll be coming out with more content shortly. I'm kind of in the middle of the dog days of senior year, so just let me know what you guys think. If you guys want to see anything, just let me know, and I'll keep on coming out with content for you guys. All right, remember to keep programming. Appreciate your time. Have a good one.